Today we'll be solving college physics, the 9th edition. We'll be solving chapter number 1, which is the introductory chapter about some things you'll be using in physics, the quantities, length, weight, mass, and how you use trigonometric functions to solve. It's just a really easy chapter and introduction compared to the rest of the chapters. So we'll be solving the multiple choice questions at the end of the chapter. You'll find it at the end. For example, this is on page 20. It's basically at the end of each chapter you have multiple choice questions. So let's start with question number 1. Rectangular airstrip measures 32.3 by 210 meters with the width measured more accurately than the length. Obviously we can see that the width it's measured to 1 decimal place compared with the length, which is a whole number. Find the area taking into account the significant figures. So obviously this is easy. The area of a rectangle, it is 32. It will be width times length. Easy, you got it. The thing is, since they're saying taking into account significant figure, the rule is the answer should be the same number of decimal places or significant figures as the least accurate answer, not the most, least accurate. So here we have the least accurate one is the length, it's 210. So no decimal places, nothing, so my answer will not have any decimal places. So the answer is 6,783. Just gonna write it here, 6,783. Let's look at the options. So to make it also, so I have my point here, so this is 1, 2, 3, and then look at the answer, the length here, it's 2 significant figures, so my answer must have only 2 significant figures. Here I have 4, so I'm gonna round it up to 2 significant figures and it will be 6,800. Got it? And this corresponds to option D. Look, the length has 2 significant figures, I must have 2 significant figures. It's always the answer will be the same number of significant figures and the same number of decimal places as the least accurate answer. Let's do question number 2. Suppose 2 quantities A and B have different dimensions. Okay, A and B, they have different dimensions. Determine which of the following arithmetic operations could be physically meaningful. So different dimensions is what? It's basically 2 different things. Like let's say 1A is a length, okay, 1 meter, 2 meters, and B is a time, yes, 10 seconds something. You have 1 meters and 1 seconds. Can you add those together? No, you cannot. They're different dimensions. You cannot add them, nor can you subtract them. What you can do with it, the meters, you can do 1 meters divided by 1 second, and this will give you speed, so you can divide it. You can also multiply them. 1 meter times 1 second, you will get 1 meter seconds. Again, this is all things that you can do with different dimensions. So here we have 2 correct answers. You can divide things in different dimensions and you can multiply them. The only thing that you cannot do is adding or subtracting them, no matter the order. Question number 3. Newton's second law of motion. As you can see, this is expressed more deeply and we'll tackle it more in greater detail in chapter number 4. But we all know Newton's second law of motion, which is F is equal to ma. Force is equal to mass multiplied by acceleration. Says that the mass of an object times its acceleration is equal to the net force on the object. Yes, net force, which is like the resultant force. Which of the following gives the correct unit for force? So we said that F, which is force, it's equal to ma. What is the unit for mass? It is kilograms. And I'm multiplying it with the unit for acceleration, which is meter per second square. This dot means that they're multiplied, so it's option A, kg, meters per second square. Question number 4. Use the rules for significant figures to find the answer to the addition problem. So I just explained the significant figures in question number 1. The rule is that the least accurate answer, the answer must follow the same pattern as the least accurate number in the question. In this case, again, you can see that the odd one out, or the odd man out, which is number 15. No decimal places, nothing. So after adding all of them together, you will get 57.573. This is what your calculator will give you. However, look at my 15. It's just two significant figures with no decimal places. So I'm gonna, since this number is greater than 5, I'm gonna add the 1 here, so it's gonna become 58. No significant figures, no decimal places. Sorry, two significant figures to match the 15. So the answer is 58. Question number 5. The Roman coptus, okay, is an ancient unit of measurement. Okay, so that's why its name is a bit weird. It's ancient, equivalent to about 445 millimeters. Convert the 2-meter height of a basketball forward to cup die. Okay, so we're going back in time and we're going back to conversion. First of all, since the equivalent scale that we have is that 1 cup tie, it is equal to 445 millimeters. Personally, it's my like way, but you can do it anyway. You can convert the 2 meters to millimeters, or you can convert the 445 millimeters to meters. I personally would convert the meters to millimeters because it's just easier, because it's milli means 10 to the power 3. So 2 meters equal to 1000 millimeters, and if you put here a cross multiplication, you said that 1 cup tie is equal to 445 so millimeters, so 2000 millimeters is equal to x. We'll cross multiply, so we'll divide the 2000 by the 445. I'll get the answer 4.49. Option C. A house is advertised as having 1420 square feet. A bit on highlight on the square. Under roof, what is the area of the house in square meters? So we have square feet and then we have square meters. So we'll have to get the conversion relationship or the conversion unit between the two, and we know that 1 feet, again we'll do cross multiplication. So we know that 1 feet here, meters here, 1 feet is equal to 0.3048. not really clear, but yeah, it's 0.3048. So, and I have 1420 feet. However, what I have is 1420 square feet. So to convert it, I'll have to do this 1 square. Don't forget, if it's cube, you will do it to the power 3. This might be a common mistake. So to get the answer, I'll have to multiply 1420 times 0.3048 cube. Sorry, not cube, square. And we get the answer as 131.9, which is 132. Answer each question with a yes or no. So each option we must answer it. Must two quantities have the same dimensions? So same dimensions if you're adding them. Yes, this we discussed, I think, question number 9. Sorry, question number 2. You can only add or subtract when they're in the same dimensions. So adding, yes. Multiplying them, no need. Just right now, a little while ago, we multiplied mass with acceleration. So no. If you're subtracting them, yes. If you're dividing them, no. If you're equating them, have the same dimensions. If you're equating them, yes. So basically you're saying speed is equal to speed, mass is equal to mass, time is equal to time. Yes, I cannot equate and say time is equal to mass, or speed, time is equal to speed, unless, but here, because I have only 2 quantities, If it's more than two quantities, I can do dimensional analysis. I can do time is equal to distance divided by speed. But here they said two quantities, and what I now said is three quantities. Hope this question understood. Number 8, find the polar coordinates corresponding to a point located -5 to +12 in a Cartesian coordinates. So the rule is to get the r polar it basically consists of r and the theta, which is the angle. So first, to get the r, you'll have to take the square of both coordinates. So x square, in this case it will be 25, because when you multiply the negative and the negative, it will cancel out to become a positive. So it's 25 plus 12 square, it is 144. You'll add them, and then you'll take the square root of that addition, which is, in this case, our answer is 13. So as you can see, we have a lot of 13 in option A and B. So my answer is somewhere between A and B. I just have to see the angle. So a little diagram to help you visualize is that you can see this is -5 and this is 12. So it is in the second quadrant, and whenever I'm measuring theta, I always measure it anti-clockwise, so it will be this whole angle. Now what I can do is that I can get this, let me change the color. I can get this small angle and I can subtract it from 180 degrees. This angle is not theta, because as I said, we measure theta anti-clockwise. So this small angle, I can get it and I can subtract it from 180 to get the big angle, which is theta. This is theta. So this is my plan. So let's see what is the angle that we get. Obviously the angle we can get using trigonometry. Again, to make it, let me just, so to get the angle, this one, I know that this height, it is 5, right? Sorry, it's 12, because on the y-axis 12, and I know that this the height of the triangle is 12, and I know that this distance from the origin to here is 5. So using trigonometry, I know that this angle, it is what to the 12. They are opposite to each other. We have three types of, you can say, sides. The hypotenuse is the longest one, and it is opposite to the 90 degree. So the straight line is the dark blue line is hypotenuse. Then the one opposite to the angle, the side opposite to the angle, is called the opposite from its name. And then the other one is just adjacent. It connects the 90 degree and your angles that you want. So right now here I have the opposite and I have the adjacent. So when I have the opposite and the adjacent, I can use toi. What is toi? It's the T stands for tan and the O for opposite. Opposite divided by the adjacent. And another thing you have to remember is that if you want to get, when you want to get the angle, we take the inverse function. You'll find it in your calculator. So we'll do the inverse of that function. If you don't have it, either it's in INV or more commonly it will be like the same tan function, but with the tan button on your calculator. But before clicking on it, you can do shift and click on that button and you will get the inverse. So tan inverse, what will be on top, what will be the numerator is opposite, which is 12, divided by my denominator, which is the adjacent side, which is 5. So the angle that I got is 67 degrees. Immediately I'm just gonna write 180 minus the answer that I got, and it is 112.6 rounded up to 113. So this is my angle. Let's do now question number 9. Which of the following relationships is dimensionally consistent with an expression yielding a value for acceleration? So this is part of dimensional analysis. I have two values and I want acceleration. Let's see what I got. So we obviously know that acceleration, it is, let's see what the question is giving me. Divide units of distance. I have x. The x is a distance. So x, unit of distance, divided by time square. So it's basically x time, I think it's ts, divided by t square. I want to get this result. Let's try with the first option. So all of the other quantities in physics, they are, you can say, they are made up from the fundamental three, which are time, t, distance, x, or meters, and distance, time, and mass, yes, and kg. But for example, speed, it is what? It is distance divided by t. Like all of the quantities, the other, like acceleration, momentum, moment, force, all of these come from the fundamental tree. So v obviously is velocity. What is velocity? Velocity, it is, so this is the one that I want. I don't have space, so I'm just gonna erase it. Keep it in mind, this is what we want, x divided by t square. Option A, it says v is x divided by t. Okay, again, the v is divided by t square, so I will have to put the t square here. So the answer for this one will be xt. I don't want xt, I want x divided by t square. So option A is wrong. Let's do option B. Again, I have v, so x divided by t, and this time it is divided by x squared, so I will have to take the reciprocal. So it will be, sorry, I made a mistake. When I'm dividing this by this, I will have to take 1 over x squared. So again, it will be, this one will cancel out, it will be 1 over tx. So this is also wrong. I'm just gonna review the first one. It's x divided by t times 1 over t squared. So x is, so it would be x divided by t cube. This is option 1. Again, it's not the correct one. Option C, v squared, so it is x squared divided by t squared. Because we know that 1v, it is x divided by t. V squared, that means both of them are what? Both of them are cubed, squared, sorry, not cubed, divided by t. So just to tell you what I'm doing, so this is because it's coming like this, and then going to divide it here. So again, I have x cube, x squared divided by t cube. Let's do the last option, option D. It's before the last, but it's one, I think it is, it will be. So v is, again, v squared, it is x squared divided by t squared, and here it's divided by x, so it will be multiply 1 over x. This one will cancel, this one is cancel, we have 1 here, so it will be x divided by t squared, which corresponds to acceleration. This is the first answer. The price of gasoline at a particular station is 1.5 euros per liter. An American student can use 33 euros to buy gasoline, knowing that 4 quarts make a gallon, and that 1 liter is close to 1 quart. She quickly reasons she can buy how many gallons of gasoline. Okay, so it's just a word problem, but it has the simplest math. Okay, so she said that you can use 33 euros. Okay, she's 4 quarts make a gallon, and we know that 1 liter is equal to 1 quart. Okay, so she has 33 euros. Let's see how many liters that will give her using this rate, 1.5 euros per liter. So for 33, I will just multiply the 1.5 with 33, and it will get me 49.5 liters. Also known as 49.5 quarts. We said that 4 quarts make a gallon, So 49.5 divided by 4 will get me 12.375. Will get me, she has 32 euros. She quickly reasons she can buy how many gallons. Said that 1 gallon is 4 quarts, make a gallon. And how many quarts does she have? 49.5. Okay, so I mixed up a little bit. I thought it is 1.5 liters for €1, but it's 1.5 euros for 1 liter. So the 33 money